Lesson 3, Velocity, Graphical Analysis. Okay, so in your guys' textbook, you can refer to pages 11 to 20. First thing we're going to do is kind of do some review on position time graphs. So, what I'm going to do is actually bring up a little gizmo thing. So I can grab this little bike and move him along, whatever. And what's going to happen is that we're going to be able to show what that graph looks like. So if I start the clock, and first thing you know or notice is that it's just like the bike's not moving, but the graph is, right? Because time is along the x-axis. So if you see a straight line on a position time graph, the thing's not moving. And then what's going to happen if I start moving in the positive direction, let's say at a constant velocity, I'm going to make like a straight line up like that. And then it's going to come to a stop again, right? Now, if I move backwards at a constant velocity, let's say really slow, see if I can make really slow constant velocity. Really slow. They passed the origin there, you saw. Oh, started over. Okay. But anyway, you could see. No, that sucks. Okay, let's do it fast again. Fast, stop, and then a little slower. Okay. So you can see that what happened there is if you're moving in like to the right in the positive direction, your slope is going to be up and down. It's going to be like going from the bottom up. If you're going left, your slope is going to be going down. So that's kind of how that works, right? And really, it's just the steepness of the slope that is just showing how fast you're going. So you can see that the first one, I had him moving faster than the second one. Hopefully that kind of helped to you guys to visualize what's happening here. All right. So pretty much like I was saying on that gizmo, you can tell that from 0 to 15 seconds, this person was moving faster than the person going, or then from 25 to 35 seconds. The only difference here is that from 25 to 35 seconds, they were moving in the opposite direction. They were moving to the left, or they were moving to the west, or something like that, in the negative direction, we're going to call it. So, as a bit of a review, hopefully it's a review. If it's not, you'll be all right. But the way that we're able to figure out how fast, let's say this first section was going, we need to figure out the slope of this section. So remember slope, and I've got this written down here too, right? Slope is equal to rise over run. You can also think about that as y2 minus y1, x2 minus x1. What that means is that if this was my point, I call that y2, this point y1. If I want to figure out what my rise was, I just go whatever y2 is minus y1, because it won't always start at 0. Like in this case, y1 is going to be 0, so it's pretty easy, but it won't always be that case. So really all you got to do is figure out what your rise is. So in this case, if I want to figure out how fast this thing was going, I'd say, well, it goes up to 12. And you can't just necessarily count the ticks on or the boxes. This one you can, because every box represents one, but that won't always be the case. You need to make sure that you're looking at what your scale is and making that relevant to what your rise is. But anyway, if I'm going up, I'm going to say, okay, this point up here goes up to 12. So 12 minus 0, my rise is just going to be 12. So my rise is 12 meters, right? That's because my y-axis is in meters. Rise is 12 meters. My run is going to be in seconds, right? And in this case, that's going to be x2 minus x1. So that's going to just be 15 minus 0. This one's easy because there's zeros involved. So this is just going to be 15. So 15 seconds. So I got my rise, I got my run. Slope is just equal to rise over run. And this is kind of the way I like to think about it more than the y2 minus y1, is just draw these triangles like I've done here, and then kind of figure out what the one side of your triangle is and what the other side of your triangle is, what your rise and your run are. So in this case, slope is just going to be equal to My rise was 12. My run was 15. My pen's not working very well. And units do matter, so 12 meters over 15 seconds. And yeah, there's something else that has units of meters over seconds. It's velocity, right? So the slope here is just my velocity. So my velocity, and technically with velocity, you should have a little arrow over top. And yeah, just a little arrow over top. It's good. So my velocity here is going to be 12 over 15. Now let's make it a decimal. It's going to be 0.8. And then I got meters over second, so meters per second. So that'd be my answer. So I've just kind of done this beside the picture here. You can also look down to see what I've done down here too, right? One thing I want to draw your attention to though is I've got this positive symbol in front of the 0.8 when I did it on the computer. All that's really referring to is that I have a positive slope, and positive slope just means that the slope is going up. Negative slope would mean that the slope is going down. Now, just as a bit of review, what does a positive slope mean? What does a positive velocity mean? Well, it just means that it's going to the right or up or whatever we made our reference be. Okay, moving on down. Okay, so we can also use this to figure out, let's go the 15 to 25 second interval. You can grab a different color. Okay, so from 15 to 25, you can see right from the graph that the slope of this thing is going to be 0, right? It doesn't have any slope. So the slope from that point to that point, so it's going to be rise over run. Well, my rise is 0, so what I'm going to have is 0 divided by the run of 15 minus 20, or 25 minus 15, so 10. So 0 divided by 10, it's going to be 0, right? So my velocity at this point is 0, which makes sense. They're not moving at that point. Okay, the next part though, I'm going to draw another little triangle. That's the way I like to do it. And we're going to say, okay, from this point down, I'm going to be at negative 10. That's where the difference is, because I got negative 10 or 12. Sorry, 12. So it's going to be negative 12 meters down. And it's negative because I started here and I've gone in the downward direction. So it's negative 12. My run is going to be 35 minus 25. So it's going to be 10 seconds. So now I just got to do the same thing. So if we write this over here, we got slope is going to be equal to rise over run. So rise is negative 12, and that matters, meters, over 10 seconds. So my slope here, or my velocity, is going to be equal to negative 1.2 meters per second. And I've also done that down here. So however you guys, whatever works best for you, you can kind of see what I've done there too. I'm going to end that video there, and the next video is going to be on velocity graphs. So I'll see you guys next video.